of the screen, I ask that you distribute the x plus 8 in its entirety. So hopefully your next step looks something like this, and if it doesn't, I'd like you to change it. X squared, parentheses x plus 8, plus 4x, parentheses x plus 8, plus 3 times the x plus 8. Now at the beginning of the chapter, we learned a method for multiplying a binomial times a trinomial. And I used a variety of methods. Either it was the distributive property twice, or we did the 2 by 3 boxes, right? But I wanted you to try this for now because it's going to really lead in to our next our lesson today. So when you do this, you would finish distributing, correct? And get what? X to the third, 8x, 4x squared, 32x, 3x, and 24. If you combine your like terms, you would get the same answer as if you did the 2 by 3 boxes or doing the distributing the x and then distributing the 8 separately. So this is just another method to do that. So now I'm just going to highlight this level of the work because now I want you to look at number 1. Notice how each term has an x minus 3. Notice how the group that I wrote circled in yellow, each term had an x plus 8. And the step before it, the x plus 8 was in front, and each of the things in front of the x plus 8 or grouped with the x plus 8 combined to make its own set of parentheses. So we're going to undistribute the x minus 3. We're going to undistribute the x minus 3. So I'm going to group the x minus 3 together, and if I take the x minus 3 out, I'm left with 4x plus 5. And that would be the answer. Factor out the common binomial factor. The binomial that they both had was x minus 3, leaving a 4x plus 5. So let's try it again for number 2. Yes, Evan?
You would get y minus 9 times 2x squared.
Good.
Isn't the second one 9 minus y?
So then that we have to change it then. Watch this. Thank you for bringing that up, so I don't miss it. On a problem like number 2, if you rewrote this to be 2y squared, y minus 9, the first part doesn't change. But if I made this a minus 3, then my terms would switch around. Because if I had 9 minus y, and I factor a negative 1 out, or a negative sign out, that's going to switch the signs of everything inside. So that gives me y minus 9. The y would become positive and the 9 would be negative. So now when you do that, you see that they're the same, right? So we were close. Y minus 9 and 2y squared minus 3. Thank you for catching that, you guys. I was on autopilot. Questions so far? We're undistributing the binomial. Okay. All right, so now when we look at problem number 3, it says factor by grouping. Well, factor by grouping is basically what we just did. Okay? This is the only way at this point that we can factor polynomials with 4 terms. So, if you see a polynomial with 4 terms, this is the method you're going to use. 4 is key here. Look at number 3, and it's written in standard form, which is helpful. I'd like you to take the first 2 terms and the second 2 terms and put parentheses around them and group them together. And you can rearrange things, and there's to better enable you to group it. I find that if you have it in degree order and standard form, then it's going to work out best. All right, so Eli, what does 2x to the third and 4x squared have in common?
2x squared.
Fabulous. So we're going to go ahead and GCF or undistribute a 2x squared. And just from within that group, what would be left inside the parentheses? Chanel. X minus 2. Very good. So I just took that first set of parentheses that I made and said, well, within those two we have, each term has a 2x squared in common. We're going to undistribute a 2x squared and be left with an x minus 2. Great. Now let's do the next set. What does 8x minus 16 have in common? Ingrid?
8.
It has an 8. So undistribute an 8. And lo and behold, what are we left with? X minus 2. So after you group them together, you undistribute something from each set, and in all likelihood, they're going to turn out to have something in common again. And we're going to repeat what we just did in problems like number 1 and 2. So Will, what should be my next step?
Try and put them together. Like x minus 2 plus.
Well, they're not going to be plus because we're undistributing the x minus 2. So it's going to be times.
Times 2x squared plus 8.
There's the plus. Good. Very good. Yes?
What happens when they don't have anything?
And you can't do much. On those types of problems, the most you can do is do a greatest common factor. So that would be our final answer for 3. So on number 4, is it written in standard form? No. It helps us with these 4-termers to when we're factoring by grouping to first rewrite it in standard form. So it starts with y to the third. Michaela, what should I write next for this to be in standard form?
Plus 2.
And then?
Minus 5.
And then?
Minus 9.
Very good. Standard form first will help us. Now go ahead and group the terms together. Kiani, what do the first set of parentheses have in common? Very good. They have a y squared in common. So when I undistribute the y squared, Tate, what am I left with?
Y plus 2.
Good. Then what does my next set have in common? Ty?
Negative. 5.
You're right. Well, actually, I do have a negative 5 in common. Because this term, before I put the parentheses there, was negative, right? So I know I put my parentheses, it kind of got in the way of the minus sign. But you do have to factor a minus out, because when you do that, this term was negative. We factored a minus out, and that makes this one a plus. So I should have, I think, moved over my parentheses so that it made that plus. So you could have seen that a little better, but I put my parentheses a little too close to the 5. You see how I got the sign change there? All right, so now they each have a y plus 2 in common, right? So put a y plus 2 in front, and what's left over? It's the y squared minus 5. There's your answer. Fabulous. Okay. So now we have our directions changing a bit. It says to factor completely. So problems like these, you are most likely going to have to GCF first. So looking at number 5, 4 and 64 are perfect squares, and yes, there's a minus sign, but is x to the third a perfect square? Is x a perfect square? No. So that 2-termer can't be a difference of squares. We can't factor it immediately, but if we GCF something, we can. Now, you could just GCF the x, but don't they have something else in common, Justine?
They also have
The multiples of 4. So let's factor out of 4x. Nice. When we do that, Kevin, what am I left with?
X squared minus 16.
Good. All right, raise your hand if you think we're done. Oh, I'm so glad none of you raised your hand. Will, what should I do next?
Okay.
You don't know? Oh, you should have raised your hand, man. I wouldn't have called on you. I'm sorry. Eli.
X squared minus 16 is a difference of squares.
Oh, you picked up on it. So what's left in the parentheses is a difference of squares. A squared minus b squared factors into a plus b times a minus b. So take the square root. Take the square root of x. We get x, put that here and here. Take the square root of 16, we get 4 and 4. If we were to refoil these, the only way for that middle term to go away is if one of them is a minus and one of them is a plus. Yesterday we learned factoring the special products, right? Difference of squares, know when to recognize it and know how to factor it. Michaela.
I don't understand what difference of squared is. Is it like when it goes to...
Difference of squared is when you have two terms and each of them are a perfect square. X squared is a perfect square and so is 16. So that one always factors into the square root of each of them. Make one a minus, make one a plus. That way, if you were to refoil it, you wouldn't end up with a trinomial like you normally do. Alright, so now this whole thing is the final answer, and don't forget to include that 4x in front. Alright, Tate, what does number 6 have in common? What does each term have in common?
I guess
3. What else?
x to x squared.
Good. And a y. So everybody, please GCF 3x squared y. One set of parentheses because we're just taking the greatest common factor. Anna, what am I going to be left with inside my parentheses?
X squared plus 2x minus 24.
Plus 2xy,
Minus
24y squared. Good. All right. Well, we're left with a trinomial inside. Let's try and factor that trinomial. Leave this outside. Let's try to factor the tri into two binomials. Coleman, what am I going to put as my first term in each set of my parentheses?
You would put x plus 6.
Oh, you already know that? I was just going to say get x and x.
Oh, sorry.
Well, pause. I'll call on you in just a moment. So the factors of 24, 24 and 1, 2 and 12, 3 and 8, 4 and 6. So we need to think of factors of 24 that result in a difference of positive 2. Coleman, you already said you knew it. Go ahead.
X plus 6 and it's not 12.
Great. How am I going to get that y squared though?
Oh, sorry. So it'd be 6y and then 4y.
Perfect. That's the complete factorization. Questions so far? Aaron.
Why do you think the y
Because if I were to refoil this, that's how I would get 24y squared. And if I were to check my smiles, that gives me 6xy. This gives me minus 4xy, which results in our difference of positive 2xy, which is what we want. All right, good questions. Other questions so far? All right, so number 7. Oh, I got a hand up already. Anna, what do you think?
Well, I think it's a difference of squares.
I agree.
I would do d squared minus 9. Times d squared plus 9. But since d squared minus 9 is also a difference of squares, I would put d plus d d minus the label.
Perfect. Absolutely perfect. So let's back up for those of you who still have some questions. The original is a difference of squares because d to the 4th is a perfect square. D squared times d squared makes d to the 4th. 81 is a perfect square. 9 times 9 is 81. So take the square root of each of them, make one a minus, and make one a plus. But the term that's a minus is factorable because it's a difference of squares again. So do it again. It's square root of d squared is d, square root of d squared is d, square root of 9 is 3. That's the complete factorization. Put a star by that one. Put 2 stars by it. I think that would be a great problem to know how to do. Just FYI. Aaron? D squared plus 9? No. It has a plus sign. The only things that are factorable are trinomials, right? That in which the factors of C add to B, or if it's we have to check a smile situation. Or we could take a greatest common factor, difference of squares, or if there's 4 terms, we look for grouping. But that's a 2-termer, so our options are limited to difference of squares or GCF. Well, we have nothing to greatest common factor, and that's a plus sign, so we can't do a difference of squares. Good questions. Ingrid,
Yeah.
help me out on number 8. What should I do first?
Well, put your parentheses.
What kind of parentheses?
Well, one big one.
All right.
One big one.
One big one.
And then the common are 3. So they all have. They all have. Is 14 a factor of? Oh yeah. So they all have 3W.
Good. So the greatest common factor is 3W. Great.
And then okay. So then you have W. Second.
Good.
And then you have 8W.
Nice.
And then you have how many times is
I'll just give it to you. How about plus 16?
Okay, and 16.
All right. So now you could say what are the factors of 16 that add to 8, or what type of special trinomial is that one, Evan?
It's a perfect square triangle.
It is a perfect square trinomial because the square root of 16 is 4, double it is 8. So we'll leave this 3W. This factors into W plus 4 quantity squared. Final answer. Questions? Megan.
If we read as 2 parentheses, will we get marked?
It's poor form, but I probably wouldn't mark you off. All right, turn the paper over and you see your classwork. Good job.